In this video, we are going to be graphing absolute value functions, regular old linear equations, and piecewise functions. All right, so as soon as I see these absolute value symbols, these vertical bars, I know this is going to be some type of a V. If it were positive in the front, it would be an upward facing V like this. But since I see the negative in the front, I know it's going to be a downward facing V like that. So do not give me a straight line when it's an absolute value function. So the parent function, y equals the absolute value of x, has its vertex at the origin, and then it goes from there. So keep that in the back of your mind. The transformations here will be left 1, up 3. So if I go left 1 and up 3, that's going to be my new vertex. Remember, the left-right motion is always the opposite of the way it looks. So that's why I went left 1. So the V is going to start here. Now, look at this negative sign as a negative 1. In fact, look at it as negative 1 over 1. So we can perform the slope. This will make the right-hand side of the V. Down 1, right 1. So if I go down 1, right 1, it's going to be like this. Now to make the other side of the V, I'm going to do the mirror image. So down 1, left 1 will be like this. So this is what the function will look like. Oh man, this is hard to draw with an electronic pen. Let me try it this way. All right, good enough. Now the domain, this goes left forever and right forever. So negative infinity to positive infinity. The range is the y values from bottom to top. Now this graph goes down forever, so I'm going to start with a negative infinity. But it doesn't go up forever. The highest value is a y value of 3, which is included, so we'll use a bracket. So that's how you do number 1. All right, let's slide over and take a look at number 2. Okay, this transformation is right 1, and that's it. It doesn't go up or down. So if I go right 1, that puts my new vertex here. Now again, this is going to be a V shape. I see the absolute value, so I know it's going to be a V shape like this. To get the right-hand side, I'm going to use the slope of 3. Think about it as 3 over 1. So rise over run, up 3 over 1. That rhymed. I'm awesome. So that's going to be like that. And for the left side of the V, I'm going to do the mirror image. So up 3, left 1. So that's going to look like this. And that's it for the graph. Now again, this goes left forever, right forever. So the domain is negative infinity to positive infinity. The range is y values from bottom to top. The lowest value is 0, because it's right on the x-axis. And it goes up forever. So the range is from 0 to infinity. All right, let's find problem number 3 and graph that. Now, notice that problem number 3 does not have any absolute value symbols in it. So this is just a straight line. So this graph is just going to be a line. And it should be downhill because I see the negative slope. Now, the 6 is the y-intercept. I'm remembering the model y equals mx plus b. M is the slope, b is the y-intercept. So that means the line will cross the y-axis here at 6. Now, the slope of negative 1, I'm going to think of it as negative 1 over 1. So I'm going to go down 1, right 1, like this. and I can repeat the pattern a little bit to the left. And that's really all there is to it. Now the domain is going to be negative infinity to positive infinity. The range will also be negative infinity to positive infinity. It goes left and right forever. It goes down and up forever. All right, now number 4 is very similar, but it is not in slope-intercept form. So we need to fix that. So I'm going to do that right here. So I have 4x minus 3y is equal to 6. I need to rewrite this in slope-intercept form. So you should subtract 4x from both sides first. That's going to give you negative 3y is equal to negative 4x plus 6. Then we will divide everything by negative 3. So that will give you y is equal to, look, a negative divided by a negative is a positive. So this will be positive 4/3 x and then minus 2. All right, 6 divided by negative 3 is negative 2. So the y-intercept is negative 2, and then the slope is 4/3. So rise over run is up 4, right 3. And do that again. So up 4, right 3. And let's do one to the left by going down 4, left 3. So down 4, left 3. All right, I think I'll cheat this time and use my technology to draw this line, because my lines are just so crooked. It's pathetic. So your line should look like this. Whoa, that's big. All right, that's what your line should look like. And of course, this goes left forever, and it goes down and up forever. So just like the last problem, the domain is negative infinity to positive infinity, and the range is the same thing. All right, how about that number 5? Let's see what's up. All right, so we have a piecewise function that we are going to graph. So let's start with the top piece, y equals negative 2/3 x minus 6. Now, on the last video that I did this by hand. I'm going to do it using the calculator this time. So using the calculator, you could hit the table button. Clear out anything that's in there. So we have negative 2/3 x minus 6. So here I go. Negative 2/3 x minus 6. Enter. Now, I want to start at my domain restriction number, 3. So I'm going to start at 3. Enter, 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 enter. So this is going to be my first point, 3 comma negative 8. So here I go. I'm going to go to 3 comma negative 8. Maybe I should zoom out. But by the way, this will be a closed circle because of the or equal to. So 3 comma negative 8 is right here, and we'll make that a closed circle. Now, I need more points, though. I want points that are less than 3 as well, x values that are less than 3. So on a calculator, lesser values will be above. So for example, 2. Now, I don't like these fractions and such, so I'm going to keep looking. Don't like it. Oh, there we go, like 0 comma negative 6. All right, would be less than. So 0 comma negative 6 is going to be another point. Let's get one more. All right, -3, -4 would be 1. So here we go, -3, -4. Now, by the time you've got a couple, you can clearly see the pattern, so you can just continue from there. So it's going like up 2, left 3. So just keep going, up 2, left 3, up 2, left 3, up 2, left 3. Okay, so this piece of the graph is going to look something like this. All right, so that's how you can do that using a calculator. And now let's do the second piece, y equals x minus 1. So back to the table, and we will do x minus, well, you know what, let me clear this out. So x minus 1. Again, I want to start at 3 because of the domain restriction. So +3. Enter, 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 enter. So my first point here is the point 3, 2. All right, and this will be an open circle because it is not equal to. So 3, 2 is going to be right here, open circle. Now I want x values that are greater than 3. So that would be like 4, 5, 6, like that. So for example, 4, 3 would be 1. 5, 4 should be right here. And again, I see the pattern. It's going up 1, right 1. So I can just go ahead. And that's it. So that's how you could use your calculator to graph a piecewise function. The domain, this graph does go left forever and right forever. So that's going to be -infinity to +infinity. Now the range is y values from bottom to top. The lowest y value is here at -8. The closed circle reminds me that it needs to be included, so I'll put it a bracket. And then after that, the function goes up forever. So +infinity. So that is it for number 5. Okay, let's move on to number 6. And this will be the last one for this video. Now, when I see these pieces that are just numbers, just a constant, no x's, I'm thinking y equals 1, y equals -6, etc. These are horizontal lines. So y equals 1 is a horizontal, y equals -1 is a horizontal line at -1, like this. Only we won't draw the whole line. We're going to use these domain restrictions. Think between. We want the values that are between -2 and +2. So on the line I just drew, here's -2, here's +2, and here's between. Now the left side should be a closed circle because of the or equal to. So it'll be like that. Okay, now let's do the next piece. Y equals -6 is a horizontal line at -6. So y equals -6 is here. But we're not going to draw the whole thing. We're just going to draw the part between 2 and 5. So here's the part that's at 2, and here's the point that is at 5. And here's between. So it's a segment. Now the left side should be a closed circle because of the or equal to. And finally we have the -8. So I'm thinking y equals -8, and again that is a horizontal line at -8, like this. So we are not going to draw the entire thing. We're going to draw the part that's between 5 and 9. So here's the point that's at 5, and here's the point that's at 9, and here's between. And again, the left side should be a closed circle because of the or equal to. So that's it. This is what the graph should look like for this type of a problem. Now the domain and range. The domain is going to be fairly straightforward. The domain is x value, so left to right. The leftmost value is here at -2. So I'm going to start at -2. I see it's a closed circle, so it's to be included. The rightmost value is here at 9. That's an open circle, so it is not to be included. There are no breaks in the domain. There is no x value that is not covered between -2 and 9. All right, this is solid from -2 to +2, and then at +2, just when this ends, the next one immediately picks up. So there are no gaps in the x values. That's not true for the y values. Here I'm at -8, because I'm going bottom to top, but then look, there's nothing. Between -8 and -6, nothing exists here. There are no y values that are being covered. So you can't use interval notation and just say -8 to -1, because that would include all the y values in between, and there are huge gaps here. You could literally drive a car through the gap in this without hitting any y values. See, it's just going through and driving through. Didn't hit any y values. That's quite a gap. Should have made it a truck. So how do you get around it? You just make a list, because there are only 3 y values here. I'm going to still go from least to greatest. So -8, and we have y values at -6, and we have y values at -1. Those are the only y values on the graph, so you can just make a list. Use braces. These are mathematical, part of the mathematical system. When you're making a list, you use braces like this. Ha! I rhymed again. I'm still awesome.